everybody. So I just got an email from a student who's working on the assignment for Chapter 6, and they had a couple of questions on the assignment. So obviously I can't do the question from the assignment, but I can do a similar question that's in the book and kind of lead you in the right direction. So the one I'm going to look at right now is under exercise 6.5, and it's problem number 5. So here, a payment stream consists of 3 payments: $1,000 due today, $1,500 due 70 days from today, and $2,000 due 210 days from today. What single payment 60 days from today is economically equivalent to the payment stream if money can be invested at a rate of 3.5%? So I'm going to tell you the very first thing you should do whenever you get these type of questions, because you can read that and it's like, oh, there's money and days being tossed around everywhere. Very first step, draw a timeline. So oops, that's not my timeline. Just one second. My timeline's here. So I uploaded this into the unit. So this is how I always start these questions, because you got to kind of visualize what it is you're trying to do. So the first one said 3 payments, $1,000 due today. So here's my timeline: $1,000 today, $1,500 due 70 days from today. So $1,500 70 days from today, and $2,000 due 210 days from today. So I have my 3 amounts on my timeline. Then it says, what single payment 60 days from today is economically equivalent to the payment stream? So 60 days is here, so we're looking to calculate what amount right here is equivalent to these 3 payments. If money can be invested at a rate of 3.5%, so I just jotted that down up here. So now I can visualize what I need to do. So the first step, this is our focal point. You need to pick one date as your focal date or focal point. So we're obviously trying to calculate what the value of those 3 payments are at this date. So this is going to be my focal point. And the book discusses that. So then we have $1,000 due today. I need to find out the value of that $1,000 60 days from now. So I'm looking for the future value. So I need to calculate the future value of that $1,000 60 days into the future. And then the value that I get for that I can put here. Then I have to figure out what the $1,500 will be worth at that 60-day mark. So I need to find the present value at this date of this amount of money, of the $1,500, which we're going to receive in the future. But notice that we're going to receive it at day 70, and we're calculating the value at day 60. So what is the value of that $1,500? What's the present value of that $1,500 10 days into the future? So I need to calculate the present value of the $1,500 10 days into the future, 70 minus the 60 days. I also then need to calculate what the value of this $2,000 that we're going to receive on day 210, what the value of that is on day 60. So again, I'm going to calculate the present value of this future amount of money that we're going to receive. So I need to calculate the present value of the $2,000, but it's not 210 days because we're looking at it at day 60. So the 210 days minus the 60 days, which is 150 days, is where the date that I need, or the time that I need to get the present value. So now that we've figured out this, now we know. We've done in this chapter, we've looked at how to calculate the future value and how to calculate the present value. You can, the solution that was posted here uses the future value and present value formulas with the 3.5% here and with the 60, 10, and 150 days. Again, it's important to understand these formulas and know how and when to use them, but for the purposes of testing, you're going to have to become familiar with your calculator. So practice doing that on the calculator if you can. And again, we recommend the BA2 Plus. That's the one the textbook uses. So I'm not going to go into more detail about how to calculate it, but it's very important that we draw these timelines. They will help you drastically.